Good afternoon to everyone. I'm Guido Rianna and I work for Fondazione CMCC, Centro del Mediterraneo sui cambiamenti climatici. Today is my pleasure to moderate this very interesting webinar concerning integrating Bayesian networks into ecosystem services assessment to support water management at the river basin scale. Today, our speaker is Vuong Pham, working for CMCC Foundation and Foscari University of Venice. But before leaving the floor to our speakers, I would like to provide a few information about our center and few extraction for the following Q&A sessions. CMCC is a non-profit research organization established in 2005. In 2015, the center became a foundation. CMCC is a scientific research organization on climate change, its interaction with society and environment, and the world of businesses and policymakers. Our work aims at protecting the environment, stimulate sustainable growth, to develop strategies for the adaptation and mitigation of climate change. The center is organized in the form of a network distributed through the country with location in Milano, Venezia, Bologna, Sassari, Viterbo, Caserta, and Lecce, which involves and connects public and private entities working together on multidisciplinary studies concerning issues of interest to the climate sciences. CMCC benefits at all from the extensive applied research experience of its members and institutional partners, Istituto Nazionale di Geofisica e Vulcanologia, Università degli Studi del Salento, Centro Italiano di Ricerche Spaziali, Università Ca' Foscari, Università di Sassari, Università della Suscia, Politecnico di Milano, Research for the Futures, Università di Bologna. CMCC scientific activities are distributed among 11 research divisions with share different skills and knowledge in the field of climate sciences. It is very hard to explain in few words the activities of CMCC, but more or less they cover all the aspects connected to the climate change, from the mitigation to the adaptation. Of course, we develop scenarios and simulation for the climate to study the climate change of the future. We are, of course, interested to assess the impacts on different fields, geological risk, agriculture, forestry, but also, for example, over the oceans, and their consequences in economic terms for the society, the environment, and decision and policymakers. Nevertheless, communication plays a relevant role in the activity of CMCC, for example, scientific articles in international journals, educational programs, events and communication activity for a public at large, dissemination activities like this webinar. So it is more or less a very brief introduction about CMCC, but now some extraction for the following Q&A session that follows the talk given by Vuong. During all the webinar, your audio and video are deactivated by default, but if you need to intervene or you can ask question, you have two possibilities. You can write in the Q&A section or use the raise hand features and I will give you the floor. I would like to recall that this webinar will be recorded and uploaded on CMCC YouTube channel and will be available by our website. In any case, if you have any further question about the webinar, please email webinar@cmcc.it. And don't forget to follow us on all our social channels. So now it is my pleasure to give the floor to Vuong for his talk. Thank you.
Thank you very much, Guido, for the presentation and also the introduction. So in the meantime, I will share my screen. So I hope that you see my screen now, right?
Yes.
Okay, thank you. So it's my pleasure to introduce our work that we published a few time ago in 2021 last year in the topic integrating Bayesian Network into ecosystem services assessment to support water management at the river basin scale. And my presentation divided in several parts. So I will quickly introduce the topic and then the case study in input variable. Then I will go to methodology. I will sum up some results and draw some important messages. But before going to the main topic, I would like to introduce you the concept of ecosystem services because maybe this topic is not familiar with some of you. So I just want to give you an overview about that. So in this image, you can see a lake and surrounding environment. So you can meet it, you can see it like maybe everyday life, but you may not aware about the potential services that freshwater ecosystem provided. So it can provide you like several services from provisioning services, for example, providing water, fish, and food, and so on, and regulating and maintaining services such as nutrient retention, or somebody else just enjoy their walking or the view, or they take a cycling path around the lake. So it owns the services it provided, and I cannot list them all, but there are many. But since it's like available access, so we have some conflict among users, and both in terms of water quality and quantity. So our main task is try to find a solution that like people can stay and can talk together, how to maximize the benefit without losing benefit from others. So for that motivation, we develop an integrated approach coupling the output from ecosystem services, climate data, and also land use data into a Bayesian network. So the aim is to identify the critical factors that allow optimizing the supply of ecosystem services, assessing the potential space to improve the capacity of ecosystem services, and consequently, we run like thousands of scenarios to assist decision maker in choosing a solution. And you can see in the image, so it's more or less like the graphic abstract of our work. So you can see on the left hand side, we have a lot of input data from hydrological data to soil data and also land use data, especially the ecosystem services data that I will try to explain you later in few slides. And in the middle is a Bayesian network that we developed in order to create a so-called ecosystem services space on the right-hand side. And this methodological approach will apply to the case study in the Taro River Basin. So it in the northern part of Italy. So we identify that these areas have conflict user, for example, agriculture, and also the extraction of groundwater and the construction of engineering flood defenses. Also, it suffered to several natural processes, for example, morphological changes and some flood event in the past. The total length of this area is about 126 kilometers with the total area of about 2,000 square kilometers. So in this slide, I summarize on the input variables that we collected, including some data from different sources, and also some of them we calculate them. And you can see the table on the left-hand side. So the blue one is what we collected, and the red one is that we calculated one. So they are in different spatial resolution, in different format. So there's a need to integrate them on before putting them in the Bayesian network models. So for the collected data is quite clear, and maybe I can explain you some of them if you are interested in. But I'm mostly focused on the ecosystem services, the red one that we calculated. And this is one of the works that we published like 3 years ago in 2019. So basically we use Invert model to quantify ecosystem services in the future using the climate change data and also land use data in the future. So you can see here different blocks, and we put them in the Invert model. We simulate the ecosystem services. So what is the Invert model? So it is a spatial explicit model to map and value potential ecosystem services and compare the trade-off among development scenarios. So it have variety of application, including carbon sequestration, water yield, nutrient retention, and sediment retention. So in which application we use mainly two modules, namely the water yield and nutrient delivery ratio, to quantify three services: water yield, total nitrogen retention, and total phosphorus retention. The most important data is climate data and the land use data. So for the climate data, we use the climate projection provided by adopting a downscaling approach. The output of the general circulation model with spatial resolution of 0.75 degrees would dynamically downscale using the resonant climate model to a scale of 8 kilometers. So the baseline was 2000 and the time frame is until 2010 with the climate forcing RCP 4.5. For the land use data, we use the land use by integrated sustainability assessment modeling platform, so-called LUISA. So it was configured as the baseline scenario of land use change up to 2050, assuming likely socioeconomic trends, business as usual urbanization processes, and the effect of European policies. So the time frame was 2010, 2020, and every 10 years until 2050 with spatial resolution of 1 kilometer. So in the end, we use those data, we validate the model, and we quantify ecosystem services in 2010, 2020, 30, and so on. Here in the image, you can see the relative chain of ecosystem services, but we also have the absolute value in those snapshots in time. So all of this data, I mean the output of the Invert model together with collected data was put in the Bayesian network. So what is a Bayesian network? So it's also called Bayesian belief network, is a multivariate statistical model representing the set of random variables. So here it denoted as a nodes, and the condition dependency represented by the link among the nodes. So the direct connection among them can be constructed based on the expert knowledge or from the empirical observation. And each node contains a limited number of states in which their origin can be belong to. So I will explain you more later when I go to the application. And this model rely on the Bayes theorem, so in which the posteriori probability is a function of the prior probabilities and the conditional probabilities of events. So the development of Bayesian network can be divided in 4 consecutive steps, from model conceptualization, model parameterization, model validation, and scenario analysis. Starting from the first phase, model conceptualization. So this phase aims to define the structure, the main variable, and the connection among variables. So you can see here the variable represented by the node, and the arrow represents the relationship among them. And then when we define this model, we can train the data with train the model with the real data by defining the state for each variables. So it can be interval, it can be Boolean, true and false, depending on the natural characteristic of the data. And then the prior probabilities resulting from the data and from the relationship among nodes are calculated inside the model. And then be able to use this model, we have to validate the model. So there's several techniques in order to evaluate the predictive accuracy of the model. using data-based driven, or it can be qualitative evaluation. And then after the model is validated, we can use it for scenario analysis. So what is scenario analysis? It is to query the posteriori probabilities of events, given that you give some evidence to the model by setting the conditional, by setting the distribution of the input variable or the sum input, not only one, but can be some input variables. So now I will move to the reapplication of our models. So you can see here, this is a conceptual model in our case. So we started with some initial model. It can highlight in the black one with the arrows and the node and so on, based on our expertise. And then this model will apply different structural learning technique, namely score-based and constraint-based. So we use our package to implement that task. So different learning techniques will suggest you different connections among variables. Some of them are meaningful, some of them are not. So we have to evaluate again the model and decide which connection we will take and which connection we don't. And then after we finalize the conceptual model, we train the Bayesian network with the collected data as I showed you before. So first we have to assign the state for variables. So it depends on the characteristic of the data itself. For example, for the land use, we label them in woodland, meadowland, agriculture, and urban classes. Why the other variable we classify in 2 or 3 classes depending on the need. For example, we interested in some input variable, for example, precipitation. So we classify them in 3 classes. The same with water yield, nutrient and nitrogen retention and phosphorus retention, since we interested in those variables. And then we apply K-fold technique validation. So we divided the data set in K-fold, and we used like K-1 fold in order to train the model. And we test the model with the rest of data that haven't been used for training. And we repeat it for K times. So in this case, we choose 10 times. So K equal to 10. So the final result, the predictive accuracy. So in this case, we use like classification error in order to quantify our the accuracy of our model. So the classification errors was about 37, 31, 33% respectively for water yield, nitrogen retention, and phosphorus retention. So it means that the goodness of it was about 63 to 69%. It's not that very high, but acceptable. Then it's ready for scenario analysis. For the scenario analysis, we apply 2 different inference techniques. So one is diagnostic or upward reference. So you start from the bottom and you infer the top part of the model. So if fixing the probabilities of the assessment endpoint. So in this case, water yield, nitrogen retention, and phosphorus retention. And you ask what's the combination of input variables. So here we are interested in precipitation, land use, and water demand. For the downward inference, so you do the other way. So you fix the probabilities of the input variable and you ask what is the output, what's the distribution of the assessment endpoint, the ecosystem services. In the next slide, I will show you some slides of this work. So first, I will show you the result of the upward inference. So when we considering the optimization of water yield, meaning that we try to maximize water use without considering the other services. So the result of model suggests that shifting the state of precipitation distribution from low to high could lead a higher value of water yield. So meaning that if you have more precipitation, it will lead to more water yield, so it lowers it. And then, but unfortunately, this message like were not clear for nitrogen retention and phosphorus retention, so they have like minor effect on these two services. And when we consider to maximize nutrient retention, the result of the model, the scenario analysis, suggests that we can maximize the value of nitrogen retention and phosphorus retention by convert on the land use classes into urban. So it was non-physical solution, because basically if you have more urban, so you will have like more source, and then the nutrient retention will increase. But you have more source, then the retention will increase accordingly. So that's why we do another exercise. We try to minimize the nutrient source. So the result of the scenario analysis suggests that we can convert the urban classes into green land use classes, for example, wetland and agriculture. So this result suggests that urban sources have significant impact on water quality related services. But more importantly, we care about the solution that we optimize on the services. So in this case, we plot on the simulation on the scenario downward propagation. So we input, we set the random input of variable, and we query what happened with the services, and we plot it here in 3 axes. And you can see here we identify 3 main zones or space. So the first one is no wind, meaning that we have low value for own services. So it highlighted in the red rectangle. And then the green one, where we call wind loss, meaning that we maximize one services while the value for other services may be low. And finally is the blue one, blue zone. So it's a win-win where we're balancing all the services. So this is very important to understand what is the combination of input lead to this maximization or lead to the solution falling in those zones. So we try to query back what is the combination of input variables. So when we considering the win-lose solution for water yield, meaning that you care about water yield without care about nutrient retention services. So it leads to the combination of high probabilities of precipitation and low probabilities of agriculture area. But you can see the trend for precipitation was significantly higher than land use. So it means that the precipitation is dominant factor for water yield. Similarly, we query the combination of input variables for the win-lose space for nutrient retention, because they have the same behavior. Then I put them side by side. And then the improvement of these services can be obtained when converting agriculture into other services in other classes. So meaning that you reduce the area of agriculture. And finally, for the win-win space, so we try to understand what is the combination of input. And the message is that the behavior is quite similar to what has been found in the win-lose solution for the water yield. That is high probabilities of precipitation, I mean high class precipitation, and low value for agriculture land use class. So it means that like water yield is dominant factor affecting also the nutrient retention services, because water use influence the hydrological and nutrient removal processes. For example, nutrient load, nutrient export, and nutrient retention as the consequence. So what is the meaning of those results to decision makers? So I highlight here some implication for decision makers. So this application is a valuable support tool to identify and prioritize the best management practices for sustainable for sustainable water use, improving water quality and balancing the trade-off among services. And also this allows decision maker to choose a specific scenario with specific configuration of land use and water demand in some case, to maximize their services. I mean the services that they're interested in. And finally, by plotting the distance pay, we can identify the gain and the loss when moving from one solution to the other solution. Finally, I would like to conclude my presentation by highlighting some strengths of the methodologies. So with the Bayesian networks, there's a possibility to incorporating the empirical data and expert knowledge in the same model. For example, to construct the conceptual model, so we use the knowledge from expertise, and then we apply different learning methods like the score-based and constraint-based methods to improve our Bayesian model, and it helps to identify some missing combination or connection among variables. And thanks to the functionality of Bayesian network, thousands of simulations were developed under different configurations, representing the uncertainty of the real one, taking into account the climate condition and land use changes. So in this case, we were able to repeat like 10,000 times. Nevertheless, this approach have few weaknesses that I would like to point out here, and maybe it will be the gap to be filled in the network, in the future work. So there was a lack of spatial temporal dynamics, even we have data for every 10 years, but we were not able to trace back to in time. And also there's uncertainty related to the sort of the data because we use data from different sources. So maybe there's some small mismatch among data, but it can be fixed by, for example, to improve the spatial temporal dynamic, we can think of a dynamic Bayesian network that allowing analyzing spatial and temporal dynamic. And to make the data consistent, so we can think of using satellite images. So many other variables can derive from satellite images, for example, water quality and land use changes. And also machine learning technique can help to increase the computational capacity. So it may be the gap and the solution for the future work. Of course, in 25 minutes, I was not able to provide you all the information related to our work. So I leave you the link here. So if you are interested in our work, you can access to the link. I also leave you my email address here, so you can contact me anytime. And especially now, it is time to discuss and ask questions. If you have any doubt, any question, so you can put the question in the bar chat, and then we can answer. Thank you very much for the attention.
Thank you, Vuong. Thank you for this very interesting talk, and because you have shared with us the very interesting findings on this test case. Now we can wait for 1 minute to collect questions, but probably I can act as icebreaker for a first question. So I would like to ask, first of all, which could be the main bottlenecks issues in extending the work, okay, in a larger areas, so other areas, or to take into account also other ecosystem services, which could be the main bottlenecks for these extensions? For example, time, or computational resources, and so on, input data. What is your feedback?
Yeah, this methodology is applicable to other scale because, like, also as suggested by the first of all, like we have to talking about the data availability, because like we have to, in order to replicate, we have to calculate the ecosystem services. So that is one of the data that we have to calculate. And then it depends on the data availability. So if you have like data for the land use, I mean, on the data table that is I showed you before. So first we have to calculate some ecosystem services. So in the extent of the model, so we can think of calculating some other services, for example, sediment retention. So it is one of the services I would like to calculate. But unfortunately, because of the data for validation, so I were not able to calculate. But in the other case study, then we can replicate and calculate. And then, yeah, I confirm that the Bayesian network and the methodological approach that we apply can be expanded to other case study in area.
Okay, thank you. We have the first question in the tab. I don't know if you can check. The question is, do you consider any water quality standard when you increase the services connected to concentration of different values, because they related to eutrophication to when at high concentration?
Yeah, I raised the question here. So do you consider any water quality standard when increasing the services to nitrogen and for retention? Yes, I mean, in this case, sorry, the answer is no, because in this case, we just simply quantify the ecosystem services. So we just take the data availability in order to build the model and replicate the historical part. And then we query the probabilities. I mean, we do not have the real value in the future, but just the probabilities of having like high concentration and low concentration. But I think in the future work, we can consider this one by defining the threshold for each classes, because like in Bayesian network, we have to classify them, but not use the real value. So maybe we can use it threshold, like for example, acceptable or not acceptable, for example. So yeah, thank you for the question.
Okay. Another
the second question, I also see here, is it possible to share the document of the and free software to apply the calculation?
Yeah, probably in specific, it could be interesting to understand if you have exploited the free software or to compute this one, or some libraries. Okay, it could be,
so I confirm that like everything I use is downloadable, and also the software I use the R and R Studio. So there was a package called BNLearn. So I implemented my work in BNLearn. And also in my publication, I also put the supplementary material where you can find all the technical information, like how I classify the data, I mean the interval, the threshold to have the interval. So yeah, they are free to download, and also R is free to download.
Okay, thank you. Another question, about in your presentation, your investigation, you have used RCP 8.5, but a question is aimed at investigating if you have taken into account also in other studies what could be the influence on the results of other scenarios, okay? If or you consider that could be a future investigation.
Yeah, unfortunately, in our work, so we didn't consider other RCP, but only RCP 8.5. Basically, due to the limitation of data. For example, Louisa were considered as the busy need as usual. So it can be assumed that like RCP 8.5, but we don't have land use for RCP 4.5 and so on. But I hope that in the future, maybe we can have like as a data set related to the RCP, maybe land use change based on the RCP. So yeah, for now, we do not consider the others.
Yeah,
RCP.
as I can understand, it is important to maintain the consistency between the model used for climate reaction, of course, and land use, because of course now it is not a problem to have the availability of climate scenarios, but it's important to have also consistent land use change.
Yeah.
So another questions that we are collecting is about how do you select the explanatory variables in your approach? If have you tried any type of data screening before the selecting the current set? Have you also tried to implement this approach with data from different areas? So we can start from this one.
Okay. Very interesting question, because it's I think basically it's a crucial point, like which variable you include in the network. So it's very important. So basically the main driver to have those variables from the invest model. So we try to be consistent with the previous work. I mean, which kind of variable we consider in the past, we have to consider in the model. And the second one, we carried out the correlation analysis. So we include the variable with the high correlation. For example, for the nutrient retention, so we have the nutrient sort, and then nutrient load, and then nutrient retention. But in the end, we keep only the nutrient retention because it highly correlated with the source. So that's why we discussed few variables from that. Have you tried to implement the approach with the data from different area? So I confirm that we haven't tried it yet. So this one is applied only for the Taro River Basin at the moment. But we can try with different approach. But of course, we have like other application for using Bayesian network, but for different purpose. For example, multi-rig assessment in the coastal area and so on, but it is not similar application in this case.
Okay.
Yes, I hope I answer well the question.
Okay. There is some other questions. How do you make sure that your model works enough to represent, conceptualize the real model? Okay, probably some additional words about the phase of calibration and validation of the model, probably, if you want, if you can.
Yeah. So how, okay, so talking about the conceptual model, so as I mentioned you before, so it was carried out in 3 phases. So the first one, we build our initial model using our expertise. Then we apply different learning techniques. So from the data driven, so the learning techniques when suggest you like different connection, but you have to verify if it's feasible or not. I mean, does it make sense or not? If it makes sense, you keep, otherwise you delete or you don't approve the changes. And then the last phase is that like we have to stay together again, and then we discuss like for every single new connection established, if it makes sense or not. So that's only step that we carried out, and also we also based on the literature review at the first. I mean, in order to create the initial model.
Okay. And another questions. So you take into account only linear type correlations. Have you also tried to check for other type of dependent structures using some coupler, perhaps?
Yeah, I confirm you that like I use linear correlation only. So maybe we can, I mean, I can try to verify again using the other methods that you suggest. So yeah, maybe we improve for the network. I mean, in terms of correlation analysis.
Okay. Some other attendee ask, of course, if you can share the presentation, but probably you have cited in your presentation the link to the paper. As I've said before, also the recordings will be available on CMCC website and YouTube channel. So we are waiting for further question.
Yeah, I mean the the webinar will be shared online, and then I leave you the link. And in case you are interested in my work, so you can drop me an email, then I will be back to you.
Okay, okay, perfect. So we are waiting for further questions, feedback about very interesting work. So another question from my side. So at the moment you use a single climate simulation chain with a single RCP, okay?
Yep.
But all the model in your side could be extended also to take into account an ensemble, for example, moving to the simulation included in neurocortex and similar, to have a clear understanding about the potential variation induced by scenario or model uncertainty. Do you think that it could be feasible?
Yeah, it's feasible to use like different data set. I mean, with the same RCP, you know, to compare and to make the uncertainty analysis based on the variations among output variable. So it is feasible to repeat the exercise with different data set. Yeah.
Okay. Okay, because probably the uncertainties in future variation of precipitation, not at all in temperature, but probably in rainfall patterns could play a relevant role, okay, in the assessment of the ecosystem services, so in cascade on all the consequences. So we are waiting for further question. Okay, we are no. Vuong, do you have additional insights that you would like to add now, or probably starting from these questions, do you consider that you can add some words about a specific part of the talk?
Yeah, I mean, only my, let's say, recommendation, I would say, is that like nowadays with the availability of the open data, so we can, let's say, we can upscaling it work to other case study area, and then we can make the assessment not only for small case study but large area. And then and also to compare the results at one of the audience were asked to compare the methodologies in different areas to make sure that like our models like work very well and calibrated very well in different areas.
Okay.
Yeah.
Okay. Probably we have another question. There is another question. Is the local government, which involves entire river basin, willing to use this as basis in their decision making? It's very interesting question, because also is my curiosity to understand how to mainstream these findings in the decision making.
Yeah. So at one of my recommendation in the end, so this tool will be very useful for decision makers, because like, okay, especially for planning, because here when you pick up one solution from the decision space, so you know what is the combinations of the input variables. For example, you see what is the distribution of different land use classes, right? So from there, you can make the, let's say, urban planning or urban planning accordingly in order to maximize the aspect that you are interested in. Because here in the space, you can maximize one services or you can maximize them both. So you will see like what is the trade-off and what is the pay value for options that you will take. So I think it's useful for urban planning.
Yes, yes. But it is important from my side to understand also which could be the most effective way, okay, to bridge the gap between these results to make really available for the decision makers, because probably it is important to provide the data in a form that could be understandable for them, okay.
Yes, so you mean like the communication, right?
Yeah. So we don't have additional questions. So I would like to thank you again, Vuong, for this interesting webinar, all the attendance, also for very fruitful discussion. And so I would like to recall that the webinar has been recorded and will be made available on CMCC channel. Okay, thank you again. Have a nice afternoon. Bye.
Thank you very much.
Thank you. Bye. Bye.